Right. Okay. Brilliant. Thanks for the introduction, Paul. Yes. So, as Paul was saying, we've been working very hard on the Dagger SDK over the last 9 months or so, and we have sort of like this last week we've like launched the PHP SDK from sort of an experimental like package into like a properly community supported package. So we've got like actual support from the community for that SDK now. So that's available. And that's really quite exciting. That's a big piece of news that we've got to sort of say today. So as of yesterday, it was launched. There'll be some links in my slides at the end that sort of got like official announcements and things we'll show. So I've called this. Well, this talk was originally called "Running with Knives." We're going to start off with a bit of a walking pace. And making sure everyone understands the problem that Dagger solves, in case you weren't in Paul's talk last year, why I think it's such a great tool. So I'm going to start looking at first at what CI/CD pipelines are, and then go over a few of the issues that exist with the current tools that people use for CI pipelines. And then we're going to have a look at how Dagger solves those problems before having a look at how to actually implement a pipeline with Dagger, with the new SDK and the module support that we've been building. So obviously, modern software, you've probably all got some sort of build pipeline that's running your QA steps, building a Docker container, doing things like PHP stan, PHP unit, maybe bhat if you're doing the BDD, following from the keynote earlier. And typically, we would configure some sort of CI server where when you push some code into your Git repository and a branch, the server will grab that code from the repository and it will run through all the steps. It'll build your image. It'll run your tests, make sure everything's looking good. And then perhaps that pipeline then goes on to publish those containers somewhere and then deploy them to an environment. Now, quite often, you're using YAML to configure that, and it looks a bit nasty, a bit like that. This was from a sort of an open source project. I pulled their GitHub Actions, I think it is, and that does actually go quite a long way off the page. It'd be sort of there's another room below this one. We'd probably be able to see the end of it down there somewhere. And obviously, not all of them use YAML, but quite a lot use their own sort of syntax. Jenkins uses Groovy. And configuring this is maybe a bit alien to people who are used to nice programming languages like PHP. It's a bit of a mess, and that's one of the things that Dagger does actually try and solve for us. So some of the other issues that we would typically have, the concept of push and pray. So especially if you've got something like the GitHub Actions, YAML, GitLab, things like that, they typically only run on the CI server unless you go to a lot of effort to set up like a local version of the runners so you can test things out locally. So most people, when they're developing their pipelines and debugging things, what you have to do is you just push up a change to that massive YAML file, see if it works. It doesn't. So you hopefully fix it this time, commit message. Push again. Oh, no, didn't work. You kind of have this sole iteration, and it really slows you down because your round trip time of like making a change and seeing that action in progress is at least the time it takes to push it, for the pipeline to run. And so you've got this kind of lag between doing stuff, and also you're making a huge commit history of every mistake you've made, which probably not something you want, really. And so you've got this like push and pray mentality of developing pipelines. Another issue that we sort of run into is the non-native tooling. Obviously, a lot of them are configured with YAML, which is, I suppose it's fairly easy for people to understand. It's just a configuration format. But if you ever had a syntax error in your YAML, it can be a bit of a nightmare to kind of figure out where it went wrong because the files are so huge. Some of the tools, Jenkins uses Groovy as well, so that's another programming language you might need to learn. I've worked in a lot of teams where DevOps teams have decided that the existing CI tooling is not great, so they've written their own sort of layer on top of it in Python or Ruby or Go or whatever they felt like using at the time, which wasn't super accessible to the PHP application team. So typically when you're working on CI pipelines, you are needing to learn a new language syntax or language entirely. Another issue is with the proprietary systems especially, it's quite hard to write pipeline configuration and code that is reusable across tools and even across projects sometimes. Building modules and sort of distributing them and reusing them is quite a task, which means that typically when you're building a new piece of, a new pipeline for a new project, you might be able to copy and paste a few bits from previous projects, but you're having to write a lot of custom stuff every single time, which isn't very optimal either. So this is where Dagger has come in to try and resolve some of these pain points. Now, it's a pipeline execution tool, so it doesn't completely replace GitHub Actions or GitLab or Jenkins, but it takes most of the configuration from those tools and puts it into code into a Dagger module. So instead of having to wrestle with Groovy or YAML, you can write PHP code or Python code if Python is your preference. So all of the pipelines in Dagger run in containers. This means they run the same regardless of where you're running them. You can run the same CI pipeline using the same Dagger command locally on your machine as will run in CI. So you can actually sit there and you can develop your pipeline steps on your machine. You can run it over and over and over until you've got it right, until it's green. Then you can commit it, put a single line to call your Dagger function in your CI pipeline file, push it up, and it will call the function. And if it's green on your local machine, it should also be green on CI. So you eliminate this whole push and pray iterative step with Dagger. It also has a GraphQL API, so it's cross-platform, and it's possible to integrate into it from any language. Any language that you can write a GraphQL client in, you can integrate into Dagger. Most of the popular languages already have a Dagger client available for them, but if not, you can use tooling that exists to generate it automatically in a lot of languages as well. So even if you're using some really out there language that doesn't have support, full support in an SDK, you can just use GraphQL to call Dagger functions and do things that way. A number of languages, PHP being one of them now, have native bindings, which allows far more, a much fuller integration into Dagger, and allows you to actually build full modules, which are then reusable. Currently, there are officially supported. There's Go, Python, and TypeScript. They're officially supported by the Dagger team. PHP is the first community-supported SDK, and there's a couple more that are sort of getting there and will be available in the coming months. And there's also a few experimental SDKs which people are still working on building. You can look those up later if you're interested in finding out what other languages you can use. Another thing that you can do with Dagger is the modules that you build are reusable. So if you use one of the SDKs to build a module, that you can publish to GitHub, and then anybody else can pull that module in and use it in their pipeline. A really cool and useful feature of these reusable modules is if you build a pipeline module for Dagger in PHP using the PHP SDK, and you've got a front-end team that is doing stuff in TypeScript and JavaScript, they can reuse your PHP module in their JavaScript pipeline. Because everything runs in a container, you can mix and match languages between the modules. And that means you can pull down a lot of the official modules, like the MySQL module and Helm modules and things like that, which are already written in Go. And you can use those as part of your PHP pipeline without having to worry about what language the original module is built in. And the interface just becomes available to your PHP code. So as I was saying, Dagger modules are one of the best features of Dagger, I think, personally. They are one of the main building blocks of a Dagger project. You can use them to both create a reusable module that you can distribute and then pull in to projects, but they're also the best way of defining your actual pipelines. And it's what we're going to spend quite a lot of time looking at today is how the modules are put together and how they work and how you can use them. What the modules do is they provide callable functions which extend Dagger's built-in GraphQL API. That allows them to be called from other modules and off the CLI in exactly the same way as you call built-in functions. In order to build a module, you need to use one of the supported SDKs because there needs to be actual support built into the engine to know how to actually run that module. So it's not just as simple as writing some code. It actually has to be built-in support, which we have for PHP now, and a few other languages, of course. And they basically get when you have a module, the Dagger engine spins up a container in the background to run your module's code inside of. So it sets up all the environment for it already, and then it provides an entry point for Dagger to call, which does a lot of the work of telling Dagger what functions are available and how to call them. You'll see that when we dig into it in a bit more detail in a few minutes. So you now should have a bit of a basic idea of what problem Dagger solves for you and why you'd want to actually start using it. So I'm going to start taking a look at how you actually start building a pipeline using Dagger, using the PHP SDK to build a module for your own code base. So the first thing you need to do is install Dagger. As I said before, it relies on Docker. So if you don't already have Docker installed, I think you'll probably need to install it first, because I don't think the install script will install Docker for you. But once you've got Docker installed, you can grab the install script, and there's instructions there for Linux, Mac, and Windows. When you run the CLI tool for the first time, Dagger will also pull down the Dagger engine and start running it in your local Docker environment, so you've got it available to actually make calls against. And it will also automatically, if you download the latest version of the CLI client, it will notice that your engine is out of date and update it for you. So the only part of the tool you need to worry about is that CLI tool. Once you have Dagger installed, you'll need to create a new module. There's two use cases that you might have here. The first is creating a module to start building pipelines with. So for your application, you've got, say, a Laravel Symfony app, and you want to package it up, run some tests. The second option is to create some sort of reusable module that you might want to share between several projects. So if you want to write a module to run PHP unit tests and then share that across a bunch of things, there's two slightly different ways of doing it. The first line on the slide there is how you would do it if you were building a reusable module. You give it a name, and it will basically put all the Dagger source code in the root directory for you. If you want to create it for an existing project, you want to provide the source parameter to the init command, which will put all the Dagger source code in a subdirectory. The convention is to use the directory Dagger, but you can put anything you like in there. If you want to put like CI or CD or something like that, that is also acceptable. So yeah, that keeps the Dagger source code separate from your project code, because otherwise, because it puts a composer JSON in and it puts the source directory in, and obviously if you've already got composer JSON, that's going to overwrite what you've got. So that parameter is important. So having a look at what that will do when you run init is it runs off a Dagger pipeline, essentially, in the background in the engine, which generates a bunch of code for you. So it generates the SDK and the GraphQL client, and it creates like a demo, like a module stub for you, which has a couple of example functions. If you run it used for the reusable module side of things, you get a directory structure like on the left, so a simplified thing where you've got the Dagger code all sits in the root, and that's for building a reusable module. And on the right, you've got what would happen if you pass that source directory parameter, and obviously it sits alongside your existing module code in a new directory. There's a few interesting things that are created here, which I'm going to go into a bit more detail in. There's a dagger.json file. There's an SDK code generation directory at the top there. There's an entry point.php, and then you've got the src demo, which I'm going to go over. Now, the demo is basically the name of your module. So if you call Dagger in your project, and your project's called my app, it will rename the Dagger pipeline to be my app. So it sort of does that dynamically named. So this is what the Dagger JSON file that it will generate looks like if you use the latest version of the engine. It's a fairly straightforward config file. It just tells the Dagger engine how to run your module. So it gives it the name, which is important for it finding the entry point to your module, the class that sort of defines your module, what engine version it was created with, the SDK, and where the source code is located. This is for the pipeline for your application one, because the source is located in the Dagger subdirectory. There's a bit more stuff that goes in the Dagger JSON, which we'll get onto later on, but that's what you'll get out of the box when you generate a new module. The next thing it also creates is a SDK directory, which contains a composer package of generated code. That generated code contains both the GraphQL client that allows calls into the Dagger engine, and it also contains a set of code to inspect your module and tell Dagger about it, and tell Dagger how to call functions in the module that you've written. So the Dagger itself creates this composer JSON, which sets all that up for you. You can add your own dependencies to this composer JSON. That does work. However, so far when I've been building things, I have not found the need to add any dependencies to this myself. Possibly if you're building complicated reusable modules for things, that might be when you come in and decide that you actually do need a new package in here. The other file that it generates is the entry point. Now, what the entry point is when Dagger instantiates your module, it spins up a container, and then it calls PHP with this entry point file. And what this entry point does is it calls into the SDK, calls an entry point command, which is just a Symfony CLI application, which does an inspection over the code that's in your module, and registers that module and that code with the Dagger engine so that it can extend that GraphQL API. I'm going to dive into more detail as to exactly how this works, but if you're interested, you probably want to just grab it in your own time and have a look on GitHub as to exactly what that entry point command does. But it just goes over the attributes, which we'll get onto. So that's what you get if you initiate a skeleton module. And you can use that to start building your pipeline. It will generate for you a Dagger object. This is what what's in the source directory initially. It has two functions, but I've chopped one of them off so it fits on the slide. The module, the class name needs to be the same as your module name. It's important to keep this, otherwise the module won't work, because it looks for that class name when it's inspecting your module. And it serves as the entry point. You can actually add additional classes to it, but this base class is needed to sort of provide access to it. Again, I'll demonstrate how that works a little bit later on. The generated code example that you get, as I say, has two functions. This is a really basic Dagger function, which creates a container, pulls in the latest Alpine Docker image, and then just executes echo. And it is telling, this returns a container function from the function, so that you actually have a container returned by it, which has this echo function called. Now, that is a Dagger function, and if you go to the Dagger CLI, you can then call that Dagger function. So you see at the top line there, we've got call container echo, which is the name of the function. We pass the argument, hello world. Dagger initializes, runs through, and at the bottom, lines 15 to 22, you can see that it has printed a representation of the container that was returned by that Dagger function. Now, one thing that we can do, which is really cool, is we can chain calls. So once we've got that container out, we can then, on the command line, call additional functions that are on that container object. So in this example here, I've called the original call from the previous slide, which returns that container, and then I've called the standard out function on the container object. And as you can see, we've now got the actual standard out from the container, so you can see what's happened with the run from that echo hello world. Obviously, that's a fairly toy example. What you'd probably be doing here is running something like PHP unit and calling standard out to get the output from PHP unit to display in your CI pipeline, something like that. You've possibly seen in that piece of code, we had a bunch of attributes on the Dagger class. There are, I think there's 7 attributes that Dagger, the module uses to define your module. They basically tell Dagger how to interact with the code that you've written. There's 2 which are pretty important, the Dagger object and Dagger function. You'll be using those all the time. Any class within your Dagger module that you want to expose and you want the entry point to look over and register functions from needs to be tagged with Dagger object. Any function that you want to be exposed needs to be public and also needs to have a Dagger function attribute on it. You're quite welcome to stick additional private functions and protected functions in your class and leave the attribute off, and then they won't be part of the API that your module exposes. So you can still use private functions internally to organize your code. You just use a Dagger function to expose it to the Dagger engine. Another attribute that we have is a doc attribute. This can be put on objects, functions, and function arguments to provide a documentation string for the user. There's a Dagger functions call that you can make with the CLI, which will tell you all the functions that exist in the module, and those doc strings will actually come up on where appropriate for the function call or the argument calls to tell users what the thing expects. The next 2 are for arrays. So you can have arrays returned and passed into functions, but because PHP itself doesn't have a way of type hinting an array of something, we need to use the attributes so that we can tell Dagger that this is an array of strings or an array of containers so that it can produce the GraphQL definitions correctly. Obviously, at some point, if PHP does introduce a way of type hinting arrays of things, we will adapt the SDK to accept that syntax as well. But for now, you do need to use the attribute. And then the final 2 are, again, a slight workaround for things you can't do with PHP. One of the built-in Dagger objects is a directory and a file. So you can pass a directory object into a function if you want to pass a directory of source code to run PHP CS Fixer on. However, it's impossible to pass a default argument to that because it's an object, and you probably want to pass the argument as a string to give it a path. So we can use the default path attribute to put a default in for a directory argument, and we can also use the ignore attribute to ignore directories. So if you want to pass your source code directory in, but ignore the vendor directory, you can add /src and add vendor to the ignore so that it doesn't actually get passed into the container, and you can do a clean install of your vendor directory. As I said, you're not limited to the original PHP class that the Dagger SDK generates for you. You can have additional objects. And this is a bit of an example I've created. This composer container object takes a container as an argument and creates essentially it puts composer as executable into the container and then provides an additional function to do a composer install. The way we've done this is we've put an attribute on the container with a Dagger object to tell the entry point that this needs to be looked at for Dagger functions, and then we've registered the composer install as a function. Now, you can't instantiate these functions, objects, except for through your entry point class. So if you've got that original entry point module, if you want to return a composer container to someone, you create a function in that which creates a new object and then returns it, and then those functions become available. So it looks a bit like that. That's how you'd access those additional objects. So part of that's probably a bit, so far you've seen lots of bits and pieces, but you maybe not quite put it all together in your head. So I decided to slide in this slide last night to showcase essentially what you might do as in actual project. This is a very basic example of Dagger and how you would build a module and a pipeline with it. I have created an object which takes a default path of your current directory, which would be the source code. We then have two functions, build and test. This has been slimmed down a bit, but essentially the build step puts composer into your container, starts it from a PHP 8.3 FPM Alpine container, and then executes composer install after adding your source code into the container. You can envisage this sort of build step as a replacement for your Docker file that might be in an existing project. And you can sort of see how you might have in your Docker file, you might have from PHP 8.3 FPM, copy composer in, copy your source code in, execute composer install. And you've got sort of the same analogies in here where you're going container from with file. It's very, very similar to how you would build with a Docker file. The second function is a test function. And what I've done there is I've simply built the container. So I've got the container with all the dependencies in with all the source code. And then on top of that, we've executed PHP unit and returned the result of that PHP unit run, which might be a success, might be a failure, but you'll get the sort of the output from PHP unit as if you'd run it locally. So there's when you are developing Dagger modules, there's a Dagger develop command which you'll be needing to use quite a lot. Whenever you change the definitions in your module, you'll need to run Dagger develop because there's a cache. In order to provide performance, Dagger engine caches the definitions of your module. So if you sort of change the attributes, add a new function, change the return argument types, things like that, Dagger won't be aware of it until you tell it, hey, I've changed something, Dagger develop, reevaluate the module, have a look at what the functions are. I've added a new one. If you don't obviously if you don't do that, you get errors because the return types from your code don't match the return types that Dagger is expecting. Another interesting feature that we have in the Dagger CLI is interactive debugging. Now, if you have a function that's not working locally, you can add the interactive flag when you call your function, and anytime an error happens, Dagger will drop you into a terminal at the point at which the error happened. So in this fictitious example, I've called PHP composer install, and it didn't work for some reason. The reason for this one is because I hadn't actually added a composer JSON file. So composer was like, what are you doing? But then, obviously, it's failed in the Dagger pipeline. I've called it with interactive, dropped into a terminal. I can go, right, okay, well, why is composer not working? I run composer install again. It goes, no composer file. Then can do like ls and say, oh, right, I forgot to add the composer JSON. So I can go back to my module, add a line in to make sure that composer JSON is put in the right place, run it again, and it obviously will then work. I'm getting through this quite quickly. As I said at the beginning of the talk, one of the best features of Dagger, I think, is the reusable modules. And I've sort of briefly looked at how we can develop a module, but part of the power comes from being able to reuse those modules. So what we can do is we can build a reusable module, we can publish it to GitHub, and then it is possible to do Dagger install and provide it with the URL to a Dagger module, and it will install your module into the code base. This is a demo module that I've created, which does some helpful PHP things. Allows you to sort of create different PHP images. It provides a couple of different objects, including a PHP container. And it allows you to sort of install PHP extensions, add composer to it, that kind of thing. So it's kind of a little bit of a utility module for doing PHP things with. You would just call Dagger install, and it will update your Dagger JSON to add this dependencies section. There's currently not a call to remove a dependency. So if you install something, realize you don't need it, or want something different, you actually just have to delete it from the Dagger JSON manually. And if you want to update it, you need to delete the pin line and then do Dagger develop to get it to pull in the latest version. So there's a little bit of work there around modules, I think, to make the user interface a little bit nicer. But yeah. And then what I think is probably the really cool feature with the reusable modules here is that once I've installed the module, Dagger will run in the background and regenerate the SDK generated code for you. And it will add additional functions to that SDK to map to the functions that were available in the module you've just installed. So here I've installed my module Sci, and you can now actually call directly that module and call the functions that exist within it. So this module has a PHP function, which returns a container object, which allows me to install extensions into that PHP container, and then grab the actual container out once it's finished building it with all those extensions. It has a function to add composer as well. And then you can call that. Now this doesn't, as I said at the beginning, this doesn't just work with PHP modules. If you had installed a Go module to say MySQL, there's a MySQL module written in Go. If you installed that, you would be able to call the functions in your PHP code that are defined in that Go module. So that means that your front-end team could work on building a pipeline for building their JavaScript code. They could have their, I don't know, Jest, is it, in JavaScript, something like that? They could have all those tests. They could build those modules. You could build all your stuff, PHP unit, PHP stan. You could write your stuff in PHP. They could do that in TypeScript. And then you can pull all that together into one sort of pipeline that builds your whole app, front end and back end. Maybe pulls in a MySQL container to run some integration tests against, and then pushes that up and deploys it to a production environment or a development environment. So you can sort of mix and match your different technologies, and different teams can be responsible for their parts of the pipeline. So this is the result of calling that module in the previous one. You can sort of see that I've just called the function regularly, and it's instantiated my PHP container, and that would be the output. Again, truncated for brevity of actually calling that that function. So obviously, a lot of that is going to be calling Dagger locally. Everything I've been showing has been terminal windows, calling it on your local machine. Once you've got your pipeline finished, you will obviously want to run that in CI. That actually comes quite straightforward. There's a couple of ways of architecting it. The first one you could do it is have one call into Dagger, one call to rule them all. In this case, you would have a lot of Dagger functions, but you would effectively create one main function, if you like, an entry point in your module, which then goes and calls all the other functions that you've defined manually inside your PHP. That simplifies your CI interface, and you can just literally just do one call and it does everything. Downside to that is that you can't parallelize it, and you sort of get one sort of big long container output in one sort of go. So it might not be optimal. So another way you could do it is if you've got, say, a test for PHP unit, PHP CS, PHP stan, you could actually put separate steps in, each calling a different Dagger function. But that is the entirety of one of my projects. Looks pretty much like that. That is my GitLab CI for one of the projects I've built with Dagger. I mean, it has to publish as well. So that's a lot simpler than if you remember back right at the very beginning when I showed that sort of YAML file that goes downstairs. Compared to that is basically what you would have as your CI config for running a Dagger pipeline, which is obviously a lot better than what you had before. A lot easier to work with, and then obviously if you've got any other additional tools, you can just add additional steps. But they're all just calls into Dagger, which you've written in PHP. Which is a lot nicer to work with. And we are actually running really ahead of time. So, I've sort of given a very basic introduction into sort of bits and pieces that you would need. Ideally, this would be a workshop, because it's kind of hard to get a grip on a new tool like this, sort of sitting and watching the slides. It's kind of something you need to sit down and do. So if anybody wants to come and see me afterwards, and I can actually show you some of the pipelines I've written and some of the more advanced examples, I'm quite happy to go through some of those. If anybody wants to see some more interesting things. And yeah, so I'm sort of hoping that you've got a feel for how this can improve your workflows, your tooling, and you're going to kind of have a look further on at what Dagger can do for you. So I've got a few links. As I mentioned at the beginning, we've literally just launched the PHP SDK as a community-supported SDK. So there's a blog post explaining that. There's also a QR code to join the Dagger Discord, which is where we offer support for the SDK. So if you want to sort of jump in and try and make some things work and you're having trouble, jump in there and one of us will try and help you out. Hopefully we can build up a bit more of a community in there of people who know what they're doing, have built things and have solutions for problems. I'm also hoping that at some point we can build some sort of standardized library of tools that can be sort of like distributed alongside popular frameworks, so that we might have a Symfony module that you can sort of pull in, and it will provide you lots of useful functions for working with a Symfony project. Similarly, someone might decide to build a Laravel one, which can do the same for Laravel, and then everyone can just like reuse chunks of code that people have written in open source. So that's sort of why I'm hoping that we're going to go in the future with this. So I think we've actually got a few minutes for questions, which I'm sure there's going to be a lot of. So if anyone would like to ask some questions.
Yeah, if you've got a question, put your hand up and I'll bring a microphone over there.
Thank you. Can you suggest any decent open source repos to use as an example?
I know Paul has been working with the Symfony team to actually move their pipeline into Dagger. I don't think that works quite complete yet, but there's pull requests. So if you actually look in the main Symfony repository, there's work ongoing to actually start building pipelines for the Symfony project itself, which is going to be a really big, complicated example to look at. So yeah, if there's anything you're wondering how to do, there's probably an example of it in that, or will be when it's finished in that project. Anybody else?
Any more questions?
Wow, no more questions.
Thank you very much, Chris. And can we give Chris another round of applause?